So we'll learn like when it comes to Hadoop, and if you want to develop a particular application. So now you guys have understanding like how to work inside Hadoop. What are the different tools? When to go for MapReduce? When to go for Hive? Right. So now if I give you a scenario, and if you have a the project requirement that's coming now, and if you want to take a call like how you are going to design the whole stuff. We are going to do a quick walkthrough about that, like how to go for a simple application design, how you will do that, and then we'll discuss about the data sets, and then we'll talk about the Oozie as well as part of that. So now think of as a client. So I will give you a requirement from the client perspective, and you as a Hadoop expert, maybe whatever role you want to play, developer, architect, lead, right, whatever the role you have. Let's try to understand how you will implement this project. So my project is very simple, guys, right? So I have basically a website. So like Reddit is one of the website we have, and where I have basically a lot of the bookmark, the URLs. And all I want is I want to have so these URLs we have used. A lot of the users come here and they do a different kind of activity. They comment it, bookmark it, share it, and all those stuff. All I want to do is I want to have my big data solution that will basically take all these the activity which users are doing on this particular site, and then based on that particular the log which I'm able to get from the users activity, give me the top 10 links, like which are the links which will be used by the by a particular sorry, which are the top links which are used by the users, right? So that's all is my requirement, and I need a big data solution for that, because I know that the volume of the data which I am dealing here is huge volume of the data. So based on this requirement, and I want a big data solution, and this is my problem statement. I would leave it to you guys to ask any question which you will need to answer in terms of implementing this project. Okay. Okay. So here is the thing, guys. So what we have is like we have the data set that is basically XML as that is available as the XML data set, and that's basically the huge the XML file which we are getting from the site. Now what you have to do is you have to basically get this data inside Hadoop. So that's the first step. So how you are going like to approach, as most of you gave here, is like whenever you have this Hadoop kind of the problem, the first thing what you will do is you will try to understand what kind of the data you are going to process. So right, because your whole set of tools, the flow, everything is going to be determined based on the kind of the data you have. So if you have structured data, you are going to set one set of tool. You have unstructured data, another set of the tools. So it's very important, right? The next time when you start your discussion about the Hadoop project, just don't start like, okay, I'm going to implement the MapReduce, or I'm going to talk about the ping. First, have a cup of coffee with your client or whoever giving you the requirement, and ask them, okay, hey, tell me about your data set. What kind of the data you want us to process, right? And then try to understand whether the data is structured data, unstructured data, semi-structured data. And based on that, you ask the next set of the question. Tell me like how you are going to make the data available. So is it like that the client is going to send you a file, and that's the way you are going to consume the data? Or is it the data is going to be available through some API call, XML data? Or is it available in some RDBMS table, and that's what you have to go and fetch? So based on these information, what you do is you decide the strategy, like how you will bring that particular data set inside the Hadoop, right? And based on that, you decide to bring the data in Hadoop. And once you decide that particular strategy, then you go for the next level of approach, like where you will decide how to process the data. And that particular stuff you will do is like based on understanding the business requirement, what they want to see from the data, what the data is available, and what kind of the computation you to do, that you will decide the implementation part. And based on the implementation and the kind of the data you have, you will go for like option like whether I should go for Pig, I should go for Hive, or I should go for directly MapReduce coding. So that will be your next level of a strategy. And once you decide on the tool, then you go is like how you are going to expose this data to the client. Right, so that will be this user interface part, like how you will present this data to the client. So this is a kind of a one flow, guys, where you have the huge XML file that you want to process as part of this Hadoop processing. And then you move, first what you do is you bring the data inside Hadoop. So that's what you have, you bringing the data inside the Hadoop processing. Then you use a set of tools, maybe MapReduce, Pig, Hive, you can use that. And then like if you want like to present the data, in our case we wanted to see a report where we wanted to have like top 10 records. So in that case what you can do is you can have your reporting tools and that can connect to the database. So what you can do is you can move this data from Hadoop to any kind of RDBMS system, and that can basically enable your reports to connect that and do the the faster reporting from there. We'll see the more details here, guys, for this whole implementation. Right, so you can go through the different phase, like the MapReduce phase, Pig phase, Hive phase. You can go through, and then that's where your data will be exposed. So in a nutshell, right, how you are going to basically put this stuff is like you will have this huge XML data set. That's what you are going to get from from the user or the client. And then the first thing what you will do is you will bring this data set inside HDFS. So sometimes what will happen, the data set will not be in the appropriate format. And in that case, what you can do is you can use this MapReduce job to basically bring some kind of a structure in that data. Even if you want to do some kind of filtering or removal of the data, you can do that. And then once you have cleaned your data with the help of like whatever the MapReduce processing or in the Pig or Hive processing, you will have basically the data which in our case it was XML data, so you can like have some XML to pass the data and give you the data in a structure. Data is in a structure format. What you can do is you can use basically Pig kind of processing to get that structured data and process that. So like we wanted to have the the rating of the data, what is the top 10 kind of the URL. So all those kind of the simplification or aggregation you can do with like the combination of the Pig and Hive processing. So you can categorize your data, you can add the rating. And if you want to basically see more details about the data or some more aggregation, you can use Hive as well. So by using the Hive query, you can see like top 10 records. So give us the top 10 record based on the URL value. You can summarize that and you can do that. Once your data is available as the aggregated data and you need it for the reporting, so what you can do is you can output this data set to any kind of the RDBMS system, and that's the way generally people do the reporting on top of Hadoop, because Hadoop has due to like the the kind of the Hadoop system is built when it comes to consuming the data like from Hive and all, it's going to have very high latency because it's a kind of the MapReduce application which it is going to run to give the data. So for reports, you need basically for the users low latency reports. So what you do is you expose all this data which you get from the Hadoop aggregation or Hadoop processing into some kind of the RDBMS structure, maybe like Teradata or MySQL, and then your reports connect to that particular database where you put the data and then consume the data. So in our cases, our data was XML data, so we can very well bring a structure out of that, and that data we can expose it through the reports. Walk through, guys. One thing is now since you have understood about Hadoop, so now you can take a better call, like when you want to go with the MapReduce, when you want to go for Pig, when you want to go for Hive, how you want to bring the data, how you want to expose the data, right? So all these clarities now there with you in terms of understanding about the Hadoop system, ecosystem, and putting all these tools together to solve basically a problem in terms of the real world problem. Only thing what you have to design is or more practices like how you will write the logic. So now we have learned about how to use Hive, how to use Pig. Only thing, based on your business requirement, now you are going to come up with your logic, how you are going to process the data with the Hive, right? What kind of the table you are going to create, which columns you are going to do the aggregation, and all those details. So in essence, right, so always whenever you will come for the Hadoop, designing the solution, you will always have this question: when shall I go for MapReduce? When shall I go for Pig? And when I should go for Hive? Right. So here is one page slider, guys. One page slide. So that will help you, to basically identify when you should approach which kind of. So basically, this is a kind of a guideline for you to approach when you want to go for MapReduce, Hive, and Pig. Okay. So now, when it comes to deciding when you want to go for MapReduce, Pig, and Hive, here are certain the guidelines, guys. So you go for MapReduce when the data set which you want to process is basically unstructured data, or it's like a lot of XML data you have and you want to bring a structure out of that and then you want to process. So in that case, you use MapReduce. Good thing with MapReduce, so guys, it's good with both the structured data as well as the unstructured data. So both kind of the data you can process here. And if you have a very complex business logic and like you want to do a lot of sorting of the data and combining the data, so all those like very highly complex logic you can do with the help of the MapReduce. When you should not use the MapReduce, like when you have some kind of the time constraint, you have the the time is not is like available to do the MapReduce job because it takes time to write the MapReduce program. And when you have a certain like the join of the data, if you remember our discussion about the advanced MapReduce, guys, how complex it is to do the join with the MapReduce code, because you have to write so many lines of the code to do the join. So that again becomes a challenge here. Case of the Pig, if your data is like semi-structured data and you want to basically process that data, so in that case you can go for Pig. Only thing is it's a kind of a new kind of the language, so that you have to learn. So basically you have to learn Pig operator, how to submit the data, all those things you have to learn. And in case if you have very small data set, so in that case again Pig may not be as suitable, because if you have few lines of the code data which you want to process, Pig is starting over the head itself will be too much than what the performance benefit you will get. In case of Hive, it's very similar to the SQL. So whenever you want to have less development time and you want to do a lot of ad hoc kind of analysis, like, okay, tell me about these 3 columns, what is the aggregated data? Add 2 more columns and then tell me like what's the aggregated data. So if you want to have that kind of the analysis, you can use Hive to do that. And you will be able to basically the process data with the help of the Hive in a very faster way. So that will be basically the less development time. Only thing what you will have is with the Hive is like if you have a lot of unstructured data or something, you will not be able to do that. And also if it is like a lot of complex business logic, so sometimes implementing that in Hive may be challenging. So now with this, right, once you have this particular understanding, guys, about like when to go for what particular stuff, right, I will share you with the data set what we have as part of this class offering, which you can go ahead and implement as part of the whole the project data set. So let me get the data set, guys, here for you. So this was the LMS access which I was showing, guys. So once you come here, the Big Data and Hadoop project, here you get this project data set as part of this last module. You have the project data set. Once you do this, you see that these data sets will be available, and along with that you will also receive an email that will have a basically link to download these data sets. Okay, so now we are just getting started with the Oozie. So Oozie is something to execute and monitor the workflow in Hadoop, and it periodically schedule the workflow, trigger the execution of the data based on the availability, and it can have both the command line and the web interface which can interact with. Okay, so when it comes to scheduling a job in Oozie, so what you have is you basically create this DAG that's called directed acyclic graph. So you decide your workflow based on the different control flow and the action node. So like you have a start, end, and kill. So these are the different workflow you have that basically tells like from where to start the job, where to stop the job, and how to basically stop a job in case there is any failure or something. And then what you have is you have the certain decision nodes, like based on certain condition you want to go for this particular flow and other flow. So all these are comes as part of the control flow which you have. Then you have this fork and join. So if you want to have 2 sub process to running that, so you can fork that stub process and it will create 2 that. If you want to join these 2 data set, again you can do the join and you can combine the data set. Right. Then what you have is like apart from that you have this action node. So that's basically do the actual execution of the job. So like suppose if you want to run the MapReduce, you want to run Pig, you want to run Hadoop. So all these action node you can use it. That like suppose if you want to read the file, you want to send an email. So all those kind of this stuff you can do with the action node. So how you write this whole workflow, guys, is basically you create a XML file. So Oozie basically it's having its own language called HPDL. So Hadoop is like you define the whole process definition language. So that's nothing but a kind of the XML kind of the file where you specify what job you want to run, what is the input directory, what is the output directory, what is the starting node, what is the MapReduce processing node. So based on that, you take this data set and you process it here. Okay, so you have this XML file, right? So what you can do is, like, suppose if you want to deploy a simple MapReduce job, so you will have a start node where the whole processing will start. Then you will have this MapReduce word count, like, so that's where the action node that will execute the MapReduce job. So it knows like how it has to create a new directory, or if it directory is existing, go ahead and delete the directory, right? So all those things, it will be part of all these action node, the MR unit, the MapReduce node which you are using, the action node which you are using. And then in case there is any failure, so like if the data set is not available, so in that case job will fail and you will basically send a kill signal. And once the processing goes, it will reach the end node, and that's where the whole workflow will complete. Okay. Then these are the workflow you have, guys. So, and the nodes which you have, so you have start and then kill. So that's basically the control flow you have. Then you have the decision boxes, like, so that's where you decide like whether to go with this particular flow or the alternate flow. And then you have the fork and join, where you want to create two subflow and join the data set. Actions, you have the MapReduce, Pig, HDFS, any kind of custom Java code you want to run. So all those things you put it as part of the Java or as part of the action node. So how you deploy this Oozie stuff, guys? So you basically create this workflow.xml file, and you create certain configuration file, like you want to like have these things parameterized, not like hard coded in the workflow, like input directory, output directory, or any other parameters, like if you want to move from dev to production. So all those things should be part of the configuration file. So once you have all this one, so you move all these files into the lib directory along with the jars file or any other supported files which you have for your program, and then any other Pig, Hive, whatever the script you want to run. So all those things you move inside the HDFS, and then you submit this job from the command line, and then it will start executing that. Right. So how you do that is you basically have this Hadoop fs-put, and then you specify what kind of the configuration file you have. So based on that configuration file and the XML file, you submit the job to basically deploy it to the Oozie server. And Oozie have its own database, guys, where it maintains all the jobs and the status of the job. So once you do that, it will basically get all the information about the job property, like what is the input data set, output data set, and whatever the workflow you have put in the XML file, and based on that it will start running the job. So you will get a job ID. So by using this job ID, you can always track that how the jobs are basically progressing inside the Oozie control flow. So you can see the information about the jobs by using job info, and you can give the job ID. It will show you the status, like whether the job is running, killed, or completed successfully, right? So all the jobs will have its own log file as well. So you can see the log in case of there is a failure. You can basically look into this log and debug this stuff. Okay, so in terms of the flow, how this happens, so Oozie has, once you submit a job, Oozie has a coordinator job. So what that does is, it basically, it basically takes care of the whole flow. So in a flow, you will decide like, okay, first I want to do the MapReduce processing, then I want to do this set of the Pig processing, then Hive, and then finally I want to scoop the data, right? So based on whatever the logic you are writing, based on that particular logic, it is going to keep moving your the flow from start and till the end. So as soon as it will encounter the end node, it will basically complete the whole workflow. And as the flow is moving, you will have the Oozie workflow engine that will basically keep executing those tasks, and it will be taking the action, like whether to run the Pig job, Hive job. So that particular stuff will be done by the Oozie framework. Now, when it comes to basically, schedule the job inside the Oozie framework, guys. So you have the different way how you can schedule the job. So you can have the workflow, like which can run every 15 minutes kind of thing. So like you have like a job which you can schedule. Let's process that every 15 minutes. So you can schedule those kind of the jobs inside Oozie. So all you have to do is you have to define the frequency as 15, and based on that, every 15 minutes, based on the starting time, it will start running for the next next 1 hour. Like every 15 minutes, it will keep running. So you can have your start time, end time, and then you can give the frequency, and it will keep running that particular the workflow which you submit it for every 15 minutes kind of thing. Similar way, if you want to have like scheduling like based on the availability of the data set, so in that case, what you can do is like you can give a particular folder where you want to look for file. Like suppose if your file is getting delivered from some kind of third-party system, and based on the file system, like you want your application like every hour to connect it to it, and then run the job. So what you can do is you can schedule that for every hour, and once you schedule that every hour, it will connect to that particular directory. Look for the availability of the data set. If the data set is available, it will do the processing. Otherwise, it will wait for the another hour. It will again pull for the data set, and then it will do the processing. So these kind of the scheduling also you can do with the help of the Oozie. So for that, all you have to do is you have to define what is the input dataset directory which you want to basically pull, and what is the frequency you want to basically go for. So based on that, like every hour, 2 hour, you want to do that. So based on that, it will go ahead and look for that every hour, and this is the directory which you will specify. So generally in Hadoop, what you will have, guys, is this the year, month, day, and hour kind of the directory structure you have. So like every hour, you can ask like to come and look for this particular log, and based on that, if there is an input log or some kind of the data set like logs are there, it will go ahead and look inside the directory. Then also you can implement, like suppose if you want to aggregate the data and then you want to run, like your data is going to come every 15 minutes, that you want to combine them together and you want to process every 1 hour kind of thing. So that kind of the rolling window implementation also you can do with the help of the Hadoop. So what you can do that every 1 hour in its processing, it can go back to last, the 4 instance, whatever it has, and then it can combine that and read the data. So what you can do is starting from current 0, you can go back to the current 3 instance, and then based on that data set, it will combine that data. And like every time you want, like tell me like last 24 hour, what is the, the numbers in terms of the top 10 URL or last 10 minutes worth the URL. So based on whatever the window you decide, it will process the data set and it will give you the output. Right, so every 24 day, 1 day kind of thing, you can get this sliding window as well. So like if you have like every 24 hour you want to process that, so every day like last 1 day of the data you want to process and see, so you can go current minus 23, so last 24 hour data it will process that and will give it to you. Okay, so these are the different way, guys, how you can schedule your job. So have you guys used the scheduling tool, guys, to deploy your jobs in production? Yeah. So now when it comes like once you deploy the jobs, right, only thing is like if you want to see the status of the job, what you can do is you can use this Oozie Web Console to see the data. So by using this Oozie Web Console, what you can do is you can give these URLs to your production support team, and they can basically monitor all your Hadoop deployment with the help of these URLs, and they can see if there is any failure, it will basically show it here in this particular URL, so that they can monitor the job. And in case if there is any failure, they can get more details about what kind of the failure it has and why it has failed. Right, so all those things you can deep dive more in the URL, and you can see the details like what time it started, how much time it took. Right, so all those kind of the details you can see it from the Oozie web URL. Okay, so failed, error, anything you can see it from here. Okay, so that's what, guys, how you will deploy all these the jobs inside the URL. So you can monitor the URL, the job status, both from the web interface as well as from the the command line interface as well. Okay. So now with this, guys, let me share you some more details here, and based on that, we will conclude this particular module. So one thing is about the data set. So all the data set is available in LMS, so you can access these data set very well here, guys. So what you can do is you can get this data set and you can start implementing this project work. So there is no requirement to have the Oozie to be implemented. All you do is you have the whole workflow that basically execute without using the the Oozie as a deployment, but at least all the logic you should be able to write and populate the data set.